second half of this note, and we're going to introduce very, very briefly a series circuit and what that's all about, and a parallel circuit and what that's all about. So this is your kind of crash course so that we have a way to begin our discussion about the different types of circuits that we're going to see. And so here we go. So we're going to start with the series circuit, and you can see a picture of what a series looks like. And the important thing to note here is that in a series circuit, there is only one path. Okay? There is only one path for the electrons to flow through. Okay, and so we can see that here we've got our 9-volt battery, and we have one path for the electrons to take as they go through this circuit. Okay, no more. There's no extra ways for the electrons to go. They have to pass through each of these elements on their way to and from the battery. So this is important. When we measure the flow or the speed of electrons through the circuit, this is going to say something to us. This tells us that the current is the same, okay, at all points in the circuit. So, and this makes a lot of sense, because if current is the flow of electrons, and we've got electrons that are going around here in our one path, the number of electrons that pass by over here is going to be the same as the number of electrons that pass by down here. It's going to be the same as the number of electrons that pass by over here, and it's because there's nowhere for the electrons to go. Okay, so if we have a certain number of electrons that start out and that are going around in the circuit, the number of them is going to be the same everywhere. It's kind of like the conservation of matter, is that electrons can't just pop in and pop out, right? There's nowhere for them to go. The number that passed by this little segment is going to be the same as the number that passed by here and here and here, and so on and so forth. Okay, so the current is the same at all points in a series circuit. However, the energy that's provided by the battery is not going to be the same. It's going to be divided by the different loads that are in the circuit. Okay, so this is going to be, we're going to say that this is split. Okay, so the energy that's provided by the battery is split between the two loads in this example, because we have two loads in this example. So we've got 9 volts, and if these are the exact same light bulb, then that 9 volts of energy is going to be split between them. So each load would receive, of course, 4.5 volts. Okay, so now let's take a look, because we've just done our circuit diagrams. Here would be the schematic of this diagram. Okay, so what we'll notice is first and foremost right here, this is 6 AAA electrochemical cells, each with a voltage of 1.5 volts, combined to make a 9-volt battery. Okay, and so that's what we see here. 6 times 1.5 adds up to being 9. We can see that we've turned our switch into the schematic. We've turned our light bulbs into the schematic. And so what we have is, we want to label the ammeter. And remember that the ammeter is connected in series to measure the current. Okay, so this is what's important about this, is that an ammeter measures the current, and we connect it in series. So when we say we connect it in series, remember that series is one path in a straight line, and so this right here is our ammeter, because it's in a straight line with the light bulbs. Okay, the voltmeter is connected in parallel, and we use that to measure the potential. We could also say we use it to measure the voltage or the energy drop across bulb 1. So here's bulb 1, and this would be our voltmeter. And you can see that this voltmeter is connected around, which means in parallel to this first light bulb. Okay, so this is different than connecting it in series, which means in a straight line with. In parallel means kind of around. All right, so that is a very, very straightforward series circuit. And again, we're going to come back to these. We're going to talk about them a lot more. Let's go on to the introduction to what a parallel circuit looks like. So here is a pictorial diagram. And again, we'll kind of demonstrate our different paths. So here's the electrons can go this way through the light bulb and out through the light bulb and then back. So that would be one path. Or the electrons could do something else. They could go through the switch, through this light bulb, and then straight back. That's another path that they could take. And so in order to really kind of visualize what this means for us, is that in a parallel circuit, there is more than one path for electrons to flow through. So here, there was two possible ways of getting from the battery back to the battery. And what this means then is the current, when measuring the speed or the flow of electrons, that's the current then is split between the two branches. And that's what we call paths. So this would be path 1, this would be path 2, and the current is split between there because we've only got so many electrons. Some of them are going to take one path, and some of them are going to take the other path. Okay? The energy, though, and this is significant, the energy provided by the battery is the same at all loads. So in this case, each load receives 9 volts. Okay? So our circuit diagram is much simpler, and you can see now why circuit diagrams are actually quite useful, is that these are much, much easier to see our different paths. So we could go this way, or alternatively, we could go this way around the circuit. And the current will be split between these two loads, between light bulb 1 and light bulb 2. All right, so two advantages of bulbs that are attached in parallel versus being attached in series. First of all, in parallel, and you can see this, if one of these bulbs burns out and creates an open circuit, then electricity can still go through the other light bulb. So if one bulb is broken, and so this is an important distinction to make, if one bulb is broken, the other bulbs will not go out. All right, that's a big deal. And each bulb gets the same energy, which we call potential, or we could also call it voltage. And that means that if multiple bulbs are attached, then they all have the same brightness. Which is an important distinction. When bulbs are placed in series, of course, they will all get dimmer because they're having to split the amount of energy that each of them gets. However, when we're in parallel, that doesn't happen, and they all have the same brightness. So this is your crash course. We're going to look a lot more at these in the real world, basically building these circuits tomorrow in class, and then we'll go from there and we'll talk even more about series and parallel circuits.